Hi there. So for the next at least 3 weeks, we will be doing business as usual, classwork, and then at the end of the unit, there'll be an assessment. So enjoy this on YouTube. This is going to be a weird feeling because I'm used to teaching math in front of students, so I'll be talking to myself for the next 3 weeks. So last we checked, we did multiplying of polynomials, in particular multiplying binomials. But we're going to take advantage of the fact that it is factored out. Before I wanted you to FOIL it out, and now I want you to leave it to be a multiplication problem, and let's see why. One of the most important things to getting into Algebra 2 is a strong foundation in what's called the zero product principle. So some of you guys are looking at this like A times B equals 0, where we don't know A or B. Well, if we don't know that, if we don't know either A or B, but we know that the product is 0, then we can conclude that one of the 3 outcomes is going to happen. So let's talk about case number 1. So the big picture is in the zero product principle that if we have a multiplication problem and the answer, product, is 0, then at least one of the factors must be 0. So for instance, let's say A can be 0 and B can be any real number. Well, so we can make any multiplication problem. Let's make the first factor 0 though. Let's give it a nice single digit number. Let's go with 7. We know that 0 times 7 is 0. So it satisfies the zero product principle. Let's go with a negative number. Let's go with negative 4. 0 times negative 4 is still 0. So 0 times negative 4 is still 0. That satisfies it. Well, let's go with a fraction. Why not? 7/8. 0 times 7/8 doesn't matter. It's still 0. So that's case number 1. Case number 2 is that the second factor, B, can be 0 and A can be whatever it wants. So let me divide this up. So A can be whatever, any real number, and B can be 0. So let's make a multiplication problem, but the second factor is going to be 0. Well, let's make it a nice positive number. Let's go with 9. 9 times 0 is still 0. Okay, let's make it a negative number. How about negative 14? Negative 14 times 0 equals 0. It doesn't matter. Negative 14 times 0 is still 0. Let's go with a decimal, but let's make it negative. Negative 11.7. Negative 11.7 times 0 is still 0. So if the first factor is 0 and the second factor is a real number other than 0, it's still 0. If the first factor is any real number and the second factor is 0, then the product is still 0. And finally, the third case is both of them are equal to 0. In this case, there's only one problem I can make. Zero times 0 is still 0. So all these cases check out. So the best analogy I can come up with is when I was growing up, I played a lot of PlayStation 1, a lot of Crash Bandicoot. And the one thing that comes to mind is when Crash Bandicoot lands on a TNT box. You have 3 seconds to get out of the way. I'm not a great artist, so bear with me. So if you have a container that says TNT, and you land on it, you have 3 seconds to get out of the way, and anything in its path is going to get destroyed, whether it be the fruit or another box or even another TNT container. So anything times TNT is going to be equal to 0, which is, oddly enough, if you want to call it the Crash Bandicoot TNT rule, be my guest. But this is one of the most important things that will get you through Algebra 2 and pre-calculus, as well as calculus. Okay, so let's get some problems in. Oh man, that's thick. Okay. So first things first, the directions are going to say find the solution set. Now remember, going back to our absolute value unit, find the solution set were the directions. Previous to that, the problems used to say solve for x or solve for the unknown variable. Well, find the solution set implies that there are multiple answers that satisfy a true statement. So for example, let's take problem number 1. You've got x minus 4 times x minus 7 is equal to 0. The goal, so I'm going to put this out here, right down below. The goal is to find all values of x that make the whole thing equal to 0, the Crash Bandicoot TNT rule. So find all values of x that make this statement true. Okay, so we're going to make all the factors, in this case there's only 2 factors, a factor times another factor equals 0. Well, x minus 4 is a factor and x minus 7 is a factor. So we're going to break those up and account for both cases. So let me rewrite the problem right here. So if I've got factor times factor equals 0, I can split them up into 2 cases. Either x minus 4 equals 0, or x minus 7 equals 0. And let me make sure you have enough space to see. So I'm just going to double check, since this is my first video, I'm just going to make sure that everybody can see. Oh, perfect. So we're going to take this one at a time. You have a choice, the left equation or the right equation, but you're eventually going to do both. I like to go left to right. So you've got x minus 4 equals 0. I need to undo the layer to get x isolated. So even though it's a very simple problem, x minus 4 equals 0, I'm still going to show my work. X minus 4, well, that minus 4 layer can be undone by a plus 4 undoing layer. The negative 4 and the plus 4 become 0, and x plus 0 is just x. Therefore, x can equal 4. But remember, the directions say find the solution set, find all values of x that make this statement true. So we're going to solve the other equation, x minus 7 equals 0. So let's do that. We have to undo that minus 7 layer to get x isolated by adding 7 on both sides. Negative 7 plus 7 eliminate to form 0. X plus 0 is x. And now we've got 0 plus 7, which is just 7. And here's the beauty. You can check your work. And obviously this is a simple enough problem that we have enough time. We're going to check our work. So I'm going to check over here. I'm going to put a little dotted line over here. So you've got x equals 4. Plug it into the equation. X minus 4, x minus 7. So I'm going to plug in x equals 4. 4 minus 4 becomes 0. 4 minus 7 is negative 3. By the zero product principle, 0 times negative 3 is 0. So that checks out. We can check the other part by plugging in x equals 7. So we've got x minus 4 times x minus 7, and I'm going to fill in that blank with x equals 7. 7 minus 4 times 7 minus 7. 7 minus 4 is 3. 7 minus 7 is 0. 3 times 0 is still 0. These are the 2 cases that satisfy the zero product principle. In other words, we found all values of x that make this statement true. Just going to check. Moving on to problem number 2. I'm going to put a whole bunch of them. Okay. Problem number 3. N minus 1 times n minus 8 equals 0. Oops, that's problem number 2. Same thing. We're looking for all values of n that make this statement true. So we're going to split it up into 2 cases. We've got n minus 1 equals 0. Or n minus 8 equals 0. We're going to undo the layers and solve for them simultaneously. So let's start with the left side. N minus 1 equals 0. I'm going to add 1 on both sides of the equation. Negative 1 plus 1 is 0, so n has to be equal to 1. We're going to do the right side of the equation now. N minus 8 equals 0. So we're going to undo that layer by adding 8 to both sides. Negative 8 plus 8 becomes 0, so we've got n plus 0, or n equals 8. And we can check our work by plugging in n equals 1 and n equals 8. So let's start with n equals 1. 1 minus 1 is 0, and 1 minus 8 is negative 7. 0 times negative 7 is still 0. Let's plug in 8. 8 minus 1 is 7. 8 minus 8 is 0. 7 times 0 is still 0. We've satisfied the zero product principle. Okay. Number 3. U plus 5 times u plus 3 equals 0. Same thing. We've got a multiplication problem. The product is 0, so we can split it up into 2 cases. Either the first factor is 0 or the second factor is 0, but we're going to satisfy both requirements. Let me get out of the way soon. Okay. So we've got u plus 5 equals 0 or u plus 3 equals 0. This time I've got u plus 5 equals 0 and I want to get u isolated. So I need to undo that plus 5 layer by subtracting 5 on both sides. 5 minus 5 combine to form 0. So we've got u equals negative 5. We're going to do u plus 3 equals 0, so we're going to subtract 3 from both sides and get u equals negative 3. So this statement becomes true if u equals negative 5 or if u equals negative 3. See if you can do the next few problems independently. Plus 8, p minus 6 equals 0. I'm going to see if there's enough space. I'm going to check the camera really quick. Yeah, there's enough space. Feel free to pause the video to do these problems independently. Okay, so we've got j plus 9 equals 0, or j plus 2 equals 0, and we're going to solve both simultaneously. Subtract 9 from both sides, and j can be equal to -9. Or subtract both sides by 2 on the other equation, and j can be equal to -2. Any questions? Well, just dug myself into a hole right there. There's nobody to talk to. And that makes me sad. P plus 8 times P minus 6 equals 0. Another thing to notice is that there is no coefficient in front of the variable, so you automatically can do a one-step equation right off the bat. You know that this is going to be P equals -8 or P equals 6. But if it's a two-step equation, then I would show the work. Number 6, k minus 12 times k plus 1 equals 0. Let's just jump right to the answer. K equals 12, or k equals -1. Finally over here, it's going to come back and bite us very, very soon. We've got conjugates in this case, x plus 5 times x minus 5. But it's important to know that these are conjugates because they result in the difference of two squares as seen in the previous unit. So we've got x equals -5 or x equals +5. Okay. I want to conclude with 2 more problems, and then we'll go on to the next unit for Wednesday, March 18th. Let's go 8. Sorry, 3 more problems, excuse me. So let's start with these 2 problems. So we've got x plus 6 quantity squared. X plus 6 is in the parentheses and is taken to the second power, so we call it quantity squared. So x plus 6 quantity squared, you know from the previous unit that we can just mirror it. But let's be realistic. X plus 6 times x plus 6 equals 0. Do I really need to split these into 2 separate cases if I'm doing the same exact equation twice? The answer is no. All I need to do is just pick one of them. So I just literally say x plus 6 equals 0, and I'm going to plug, and I'm going to subtract 6 from both sides and get x equals -6. And we can check our work in this case by going back into the original problem. I'm going to plug in x equals -6. So I'm going to go x plus 6 quantity squared, but the input for x is going to be -6. -6 plus 6 is going to be 0. 0 squared is still 0. So that satisfies what the directions are asking us to do. Same thing over here. N minus 3 quantity squared equals 0 can be rewritten as n minus 3 times n minus 3. But let's be realistic. If it's the same exact expression, set equal to 0, I've got 2 factors that are exactly identical. So there's only one solution. So we bring this down. I say n minus 3 equals 0. So if n minus 3 equals 0, I need to undo that layer by adding 3 to both sides. So 0 plus 3 becomes 3. I'm going to check my work by plugging it back in. So if I plug in blank minus 3 quantity squared, where the blank is going to be 3, now I'm in business. 3 minus 3 is 0, and 0 squared is still 0. The zero product principle still gets satisfied. Please complete this problem independently by pausing it. Q minus 7 quantity squared equals 0. Please hit the pause button to do the work independently. Okay. So now we've got Q minus 7 quantity squared. Well, once again, this is the exact same problem, so why don't we just, well, not the exact same problem, but the Q minus 7 times Q minus 7 equals 0, so we've got two identical factors, so we can just get one solution out of this. We've got Q minus 7 equals 0, and I'm going to undo that Q minus 7 layer. Sorry, we're going to undo the minus 7 layer by adding 7 to both sides. Therefore, Q is equal to positive 7. Thank you for your time, and I will see you Wednesday, March 18th.